Alright, so now let's do another example. And this time, our f of x is an incomplete quadratic. Say, x squared plus 5x. Okay, but we need to set that to 0. So I'm going to write 5x is equal to 0. X squared plus 5x is equal to 0. There we go. So this one is an incomplete quadratic. So I'm going to write here, incomplete quadratic. So what do we do to solve this? Okay, so whenever you have an incomplete quadratic, it doesn't have a constant term. So if it doesn't have a constant term, then x could be easily factored out. So for example, we have x squared plus 5x. We factor out the x, and we're going to be left with x multiplied by x plus 5. All right, so there we go. So as you can see, by the looks of this, you can just cancel out the x because you have 0 on the other side, right? So, for example, you can do this, so you're going to end up with something like this. No, don't do that. You never want to do that because, remember, quadratics always have two roots. And if you do this, if you eliminate the x here, the other root will be completely lost. So you never want to do that. So let's undo that. Okay, so whenever you have something like this, you have a factor and a factor equal to 0 on the other side. So what you want to do is you want to split your equation. You want to branch out your equation into two separate equations, okay? So on this side, you take in this factor, the x, okay? You take in the x. So you have x is equal to 0 on this side, and on the other side, you have x plus 5 equal to 0. There we go. You branch out your original equation, which is this, into two separate equations. This and this. Alright, I hope you understand that. So here, you already have one of the roots. So this is one of the roots. So this is one of the roots. And this one, of course, you have 5 on this side with the x. So what do? So you move the 5 to the other side. So x is equal to minus 5. And there we go. We now have two roots, 0 and negative 5. So x is equal to 0, x is equal to negative 5. So we want to check that, right? So, okay, so now we want to test if these roots are correct. So which one do we want to try out first? Let's try 0 first, okay? So let's try f of 0. So f of 0 is equal to 0 squared plus 5, 0. Okay, multiply to 0. So here, you're going to end up with 0 plus 0, 0. So this is correct. So this is correct. I'm going to put a check mark there. So what about f of negative 5? Let's try that out. So here, you're going to have negative 5 squared plus 5 times negative 5. There we go. So negative 5 squared, that's positive 25. And here you have positive 5 times negative 5. That's going to be negative 25. So you're going to end up with 25 minus 25. You're going to end up with 0. So this is correct. All right. All right, so let's do another example. Here we have 2x is equal to 40x squared. All right, so we have that equation. So what do you first notice? Well, the equation is not in general form. So let's do this. I'm going to put here, not in general form. So it's not in this form. Okay, so we needed to make it into this form, into the general form to make our lives easier. So how do we do that? So we just put the 2x and 40x squared together on one side. And I'm going to make that the left side, okay? So I'm going to write here, since we have x squared term being the first term, so I'm going to write 40x squared first, and then together with minus 2x is equal to 0. Okay, so what do you notice here? Can we factor out a number? Do we have a common factor for all the terms? Yes, we do. We can divide by 2. we can divide by 2. I'm going to divide that by 2. So here, we're going to get 20x squared minus x is equal to 0. Okay, so we now have smaller numbers, the smallest numbers that we could possibly have. So that made our lives a little bit easier. Here, as you can see, we have an incomplete quadratic. Whenever we have an incomplete quadratic, we can just safely factor out an x. So we factor out the x, so we get x times 20x minus 1. That's equal to 0. So as you can see now, we have 2 factors on one side and 0 on the other side. So you might be thinking that you can just safely cancel out one of the factors. But no, because if you do that, again, you're going to lose one of the roots, so you never want to do that. So instead, what you want to do is to split the original equation into 2 separate smaller equations. So on the left side, we're going to get x is equal to 0, and on the right side, we're going to get 20x minus 1 is equal to 0. So as you can see on the left side, we already have one of the roots, which is x is equal to 0. But on the right side, we still need to pretty much isolate x. Okay, so how do we do that? Well, we can first start moving the 1 to the right side. So negative 1 here on the left becomes 1 on the right side. And then we just copy the 20x. And then we divide both sides by 20. So what are we going to get? So we're going to get x is equal to 1 over 20. There we go. All right. So let me erase this just to make more room. All right. Okay, so next, what do we need to do? So I'm going to put a boundary here. We need to check. So we need to check if our roots are correct. Okay. So whenever we check if our roots are correct, we need the equation in general form. We need the original equation in general form. So we can pick this equation or this. Just pick one. So I want to pick this because this is our original equation in general form. So I'm going to use this. The 40x squared minus 2x is equal to 0. And then to check, we're just going to plug in 0 for the x. So we're going to first check this. We're going to first check that. Okay. So here I'm going to write 40 times 0 squared minus 2 times 0. That's equal to 0. So we get 0 here minus 0 is equal to 0. Okay, so 0 is equal to 0, so that is correct. So we get 0 is equal to 0, so this is correct. Okay. Next, we need to check the other one. So I'm going to write here 40 multiplied by 1 over 20 squared that minus 2 times 1 over 20 equal to 0. Are we going to get 0? Let's check. So we have here 40 times 1 over 400 minus 2 times 1 over 20 equal to 0. So here you can just cancel out one of the zeros to make it a little bit easier to look at. So 4 divided by 40, that's actually 1 over 10. And here we have 2 divided by 20. So we have 1 over 10. So 1 over 10 minus 1 over 10, that's 0. So we have 0 equal to 0. And then that confirms that 1 over 20 as one of the roots is correct. All right, so we're done. So in the next video, we're going to do complete quadratics.